Hello student, welcome back to my channel Kunal sir at JEE NEET Chemist World. Comparing to the last couple of videos where I discussed the different model questions of JEE Advanced, which is specially based on the physical chemistry, today I am going to discuss also the JEE Advanced model problem but based on the organic. Now if you look at these two reactions, it's nothing but a one to diol is there, and in that diol they are giving the acid and heat. Generally in your book you will see they will give concentrated H2SO4 with heat, and instead of that here they are giving you H plus and heat. Now 1 to diol, that means one position also all, OH means all as per IUPAC name, and two positions also will be all. So that's why 1 to diol acidic catalyzed reaction, very famous reaction, and it's the preparations of ketone and the reactions of alcohol, acid catalyzed. Now these reactions everybody knows, very important reaction which is nothing but a Pinacolone rearrangement, Pinacolone rearrangement, and acid medium, this type of rearrangement used to occur. Pinacol means it's 1 to diol, and pinacolone means it's nothing but a ketone. So that's why by this rearrangement we used to prepare the ketone. This is one of the famous method for the preparation of ketone, so which can be connected with a alcohol as well as it can be connected with a aldehyde ketone chapters. And as far as organic is concerned, maximum time JEE Advanced question used to come based on the famous reactions like a hydrogenation oxidation reaction, like a Pinacol Pinacolone rearrangement, like a your aldol condensations, Cannizzaro reactions. Based on the famous reactions only, if you search last couple of year JEE Advanced question, based on the famous reaction only question used to ask, which is there in NCERT. Only the structure what they will ask in the question, that is maybe not be there in NCERT, but the reaction and all concept, everything there in a NCERT. So now if you look at the weightage for organic, the last couple of years was there a very good percentage, around 40 to 50% organic question was there in JEE Advanced paper. Minimum 6 to 8 questions used to ask, some session 11 question also used to ask from the organic. Among that, the famous name reaction questions or rearrangement questions, directly 5 to 6 questions they used to ask. That's why I choose this famous reaction, Pinacol Pinacolone rearrangement, but very tricky way they ask the questions. First, let us look at what is Pinacol Pinacolone rearrangement. Few points we will discuss based on the Pinacol Pinacolone rearrangement, and then I will come to solve these famous two questions. Let us look at what is Pinacol Pinacolone rearrangement. Suppose if I am taking like this R, C, R, OH, OH, R, C, R. OH. Now if you look at here, all are same. Now here if you look at 1 2 position, this is this is my 1, this is 2, that's why this is 1 2 diol. Now this 1 2 diol, this is nothing but a 1 2 diol situation. Here if you give H plus, then what will happen? This is a reversible reaction, my dear. So now that lone pair of oxygen is there, it will act as a nucleophile. H plus will act as a electrophile and it will donate the electron, and this alcohol will be, one of the OH will be protonated form, alcohol to protonated alcohol. So then immediately you will get like this R and OH, and then OH2 plus and R. Now it's a reversible reaction. Now oxygen is highly electronegative element. On that element, if there is a plus charge is there, then immediately it want to neutralize by taking the electron pair from the carbon, and it will depart as a minus of H2O, and then immediately carbocation used to form. Immediately carbocation used to form, my dear. You look at the carbocation used to form. This carbocation is a reaction intermediate. Then after that, what we have to see? This carbocation, once this carbocation are forming, then immediately from the other terminal, that group will migrate to this carbon. Always anti to leaving group migration will be there. Anti to leaving group migrations will be there. Migration will took place, as well as this migration, this R group is migrating to the carbocation carbon. Why? Then this carbocation will get stabilized due to the direct plus or effect of the lone pair of oxygen. So now this is a migrate, and now we will get like this scenario. You will get like this R group is migrating. So then you will get like this type of pictures. Look at here, there will be no R group, and now you will get like these pictures. If you look at, so here OH, and then here you will get carbocation, and this R is migrated to the adjacent carbon, and now here you are getting 3R, and this situation is developing. And this migration, this is a migration, and this migration is a RDS. RDS means rate determining step. Whenever there any reaction is proceed with a multi-step process, the slowest step of the process is called as a RDS, rate determining step. Suppose if you look at, you are going A to B, B to C, and C to D. Now ultimately from where to where I am going? I am going A to D. Now B to C, always there is a traffic jam. Sometimes 2 hours I have to stand in the point of B. Sometimes 4 hours I have to stand in the point of B to overcome the point of C. So A to D, ultimately how much time it will take, it will depend on the how fast I can overcome the or cross the B to C. So that's why B to C is the slowest step of the process of a multi-step process. That's why B to C will be my what? RDS. Likewise, whenever any reaction is proceeding with a multi-step, that means non-concerted way, so then among that which step is a slowest step, that is controlling the overall rate of the reaction, and that is called as a rate determining step. Always RDS will be nothing but your slowest step of the multi-step process. So here migration is a RDS. Now always leaving group was there what? H2O. Protonated from a alcohol means H2O, oxygen plus charge. That is my leaving group. You look at this, H2O is departing. This is Lg. Lg means leaving group. So that's why anti to leaving group means this R is migrating. So now that's why I write down always anti to leaving group migration will be take place. Very important thing for the Pinacol Pinacolone rearrangement. Now after that what will happen? After that, if you look at, this is a totally reversible reaction. After that, direct plus R will give by this oxygen lone pair. Oxygen has a 2 lone pair. And then immediately you will get R, C double bond O, and oxygen giving lone pair means here H, and here you have a R, R, R. Oxygen is highly electronegative element. It can't bear the plus charge on this. Then immediately what it will do? It will take the bonded electron pair from the hydrogen and leaving the H plus. And you know it is H plus was a catalyst initially consumed, finally coming up from the system, and then immediately you look at RCr and A plus byproduct as a catalyst comes out. This is nothing but your ketone, which is called as a pinacolone, and this is nothing but your pinacol. Now that's why this reaction is a Pinacol Pinacolone rearrangement. Now the question is, here everything was a same symmetrical group was there. That's why any place I did a protonation. But if the surrounded group of the 1,2-diol are not same, where will be the protonations and who will migrate? Based on that we need to get a clarity. So 2 example I am giving and you will get a clarity on that. Now if you look at, if I am taking like this situation, suppose I have pH, phenyl, pH means phenyl group, everybody knows. pH means what, my dear student? Phenyl group. And here I have a Me. Me means what? Methyl group. So pH means which group? Phenyl group. Phenyl group. And methyl means which group? Methyl, Me means which group? Methyl group. Methyl group. Now question is, here if I give H plus, where there will be a H plus and heat. That means same Pinacol Pinacolone rearrangement, which is the acid catalyzed reaction. And you look at one possibility here, carbocation generation, protonations from alcohol to the protonated alcohol, and carbocation generations over here. And another possibility left hand side, carbocation generation. So always first point, first step, protonation will occur. Protonation will occur to that OH group after removal of H2O. The carbocation generated, C plus means carbocation, C plus generated will be maximum stable. So now first step, protonation will occur to that OH group after removal of H2O. The C plus means carbocation generated will be maximum stable. In that OH, protonation and removal of H2O will be there. Now you look at, there are two possibilities. First possibility is what I am showing. Here protonation, okay, and from here this bond will be broken out. Then this is the first possibility. Then what you will get? We will get like this situation, pH, C, pH, OH and C, Me. This is the situation. Now if you look at this carbocation, already 3 degree carbocation, and stability of carbocation is 321. Everybody knows 3 degree is greater than, 2 degree is greater than, 1 degree, and 1 degree is greater than only methyl carbocation. So stability of carbocation stability, C plus stability means carbocation, my dear. C plus is representing carbocation. 3 degree is greater than, 2 degree is greater than, 1 degree. So this is a 3 degree carbocation which is stabilized by the hyperconjugation of 6 alpha hydrogen. And now their next possibility, second possibility, that the protonations will be there over here and this bond will be broken and then you will get a carbocation over here. So whenever non-equivalent position is there, then where is the protonation? That is our focus for the discussion. Now here carbocation generated means this benzene ring will give plus R and 5 resonating structure, and this benzene ring will give plus R which providing you 5 resonating structure. So that's why 10 resonating structure. Electronic effect wise, aromaticity is greater than, equivalent resonance is greater than, normal resonance is greater than, hyperconjugation is greater than, inductive. So compared to the hyperconjugation, resonance effect is stronger effect. That's why the second possibility is the major path. This path will be the major path for the generation of immediate carbocation. So that's why that OH will get protonated after removal of what immediate carbocation will be formed. That will be the maximum stable by all other electronic effect you need to consider. So now that's why here only has a hyperconjugation. Here what effect? Hyperconjugation effect. But this carbocation is stabilized by what effect? 10 resonating structure, resonance effect. Resonance effect is stronger than hyperconjugation. That's why this path will be your favorable path, carbocation generated. And here you know very well anti to leaving group migration. This group will migrate over here. Again carbocation will be over here, which will be given plus R of oxygen, and last step proton loss. That means ultimately final product, if I write down, these will be your final product. What will be your final product? These will be your final product, my dear. These will be final, and this is called as a major product. We used to call it as a MA. and minor product is mean. So that's why these will be your major product. That's why first you have to consider where the immediate carbocation will be formed, that is which place will get maximum stability, that place protonation and removal of water and carbocation generated. After that, migration. Regarding migration, if I say few points, migratory aptitude, hydrogen is greater than phenyl ring is greater than CMe3 tertiary butyl group, which is greater than Me2CH group, that means 3 degree, this is a 2 degree, which is greater than ethyl group, which is greater than methyl group. This is the migratory aptitude. Migratory aptitude is hydrogen is greater than phenyl is greater than tertiary butyl, secondary isopropyl or secondary propyl group, and then ethyl and then methyl group. So that is a 3 degree, this is a 2 degree. So that's why this side will be your group, this side, not this side, Me2CH and ET and methyl. Now this is a migratory aptitude. Based on that, if I do one questions, suppose if you have equivalent situation, like this situation, equivalent, whenever non-equivalent is there, that place protonation which can result the stable carbocation or strongest carbocation, that is your consideration. Now if you look at both are equivalent, any one you make it protonation, here also H plus and heat, any one place you do the protonations. So here I am doing the protonation and this bond is rupture, and then immediately what I am getting, I will get like this situation. So now you will get like these situations. So here Me, here phenyl and here carbocation. Now anti-2 leaving group migration will be there. Suppose you will feel, sir, anti-2 here, which is anti there, how this group will, if any group migratory aptitude is more but not there in anti position, how it will come? So carbon-carbon single bond rotation is easily possible. They will orient that way. They will orient themselves so that that migratory aptitude which has a more, it can come into that position for the further migration. So now if you look at, there is a competition between phenyl and methyl for the migration. As per the logic, we know phenyl group migratory aptitude is greater than the methyl group. Migratory aptitude directly proportional to the electron density of the group. So that's why if you look at, so obviously who will migrate over here? So now phenyl will migrate. Some people will think, sir, how phenyl is not anti-2 leaving group? They will orient themselves. That means ultimately they will come like this configuration where phenyl will be over here, methyl will be over here, and situation will be like this. So they will become like this situation. And now phenyl group has a more migratory aptitude than methyl group. So that's why this phenyl group will migrate. And then here carbocation proton loss, directly I am writing the product after that. So this will be your product. These will be methyl, phenyl and phenyl. Another important point, whenever the migratory group is migrating, if it is a chiral center possessing that migratory group, that there will be retention of configuration. That migratory group will not get chance to change its configuration. Why? Because it will not fully detach from the main moiety or main structure of the reacting species. So that's why there is no chance of a inversion of configuration of migratory group. If migratory group itself is a chiral, even though there will be a retention of configurations. That is the idea. And now this is my final product. If you have another example, suppose if I have like this, if you look at, if you have like this situation, so both OH is there. Very nice example, these things. Any one equivalent position protonation. So then what will happen? Any one position protonations over here, and then immediately what you will get? You will get like this situation. So you will get here OH2 and here your OH. Now this will depart it, and then immediately you will get like this situation. And you will get like this situation. Here you have a plus charge and here OH. So then here what will happen? Ring expansion. Here what will happen? Ring expansion. 4-membered ring will be converted to the 5-membered ring. So then ring expansion will occur. You will get like these pictures. What pictures you will get? You will get like these pictures. So you have like this. So here, and now this is ring expanded. So here I will draw this picture. You will understood. Here these things will be like this situation. Here you will have like this, like this, like this, and this was there this situation. This was there like this situation. Now this ring is expanded. It will come over here, and here your OH, and here this plus. That means after that you know proton loss and this donation and this proton loss. That means 5-membered ring adjacent position 4-membered. Then your product will be like this situation. 5-membered ring. This is your 5-membered ring. 5-membered ring here. Suppose if I draw here keto, and then keto, where will be keto, and next carbon there will be 4-membered ring. Then your situation will be like this. These will be your product. This type of situations will come because here will be keto, and then the next carbon will be 4-membered ring. This will be your final product will be like these situations. Understood? Everybody understood? Now let us come into our discussion. What is the original question which is there in a first slide? So now if you look at the first slide, there is a very fantastic questions which is JEE advanced model. In that JEE advanced model, what they ask, if you look at, you will get confident as well as you will never make a mistakes of this type of questions. Now you look at here cis and here trans. Now whenever cis is giving for this question, first I am drawing, you need to draw in a chair conformations. If you draw in a chair conformation, cyclohexane chair conformation, and this is a 1-2 position cis. 1-2 position cis means one axial, one equatorial. Trans means 1-2 position trans means in a chair, then both axial or both equatorial, but both equatorial will be favorable. Why? Because it will be exposed to outside. Now this is I am doing. Cis means one OH I am putting axial and other I am putting equatorial. This is your 1-2 cis. Now here this proton I am getting protonated. This proton I am getting, this OH getting protonated. And then immediately why? Because axial positions is steric. 1-3-5 diaxial interactions will be more. That's why axial position any bulky group, they want to get relief from the steric hindrance from 1-3-5 triaxial steric hindrance or repulsion. So that's why these will be protonated. Now once this is protonated, then immediately here carbocation is generated. I am not showing entire step. So you know protonation, departure of H2O directly I am showing. Then carbocation is generated where? Then this is your carbocation generated. So this place you have a carbocation and you have a here equatorial position OH and here you have a H. Anti to leaving group migration. That's why this is, you look at it. With respect to this OH, this is your leaving group converted to protonation H2O plus, and that is your leaving group. Then anti to leaving group means this is your anti to leaving group, and that will migrate over there. And then immediately what you will get? You will get like these structures. You will get like these structures. Here there will be both axial and equatorial position is hydrogen, and here you have a OH and here you have a plus. After that you know very well, here this donation and proton loss, final product is nothing but this one. These will be your final product. So this is cyclohexanone will be your final product. This is your final. So this is, that means here what is your Ma? Here Ma is nothing but a cyclohexanone. These will be your Ma. That is only I draw over here. But whenever they are giving trans, then what is going to happen? Trans means the situation is that if you look at trans means what is going to happen? Situation here itself I am drawing. Trans means cyclohexane. Cyclohexane, this conformation. Then 1-2 position trans means both are equatorial, preferable conformations. So here hydrogen, here hydrogen. Now anyone I get protonated. How it is OH2 plus forming? This is taking the plus of H plus and converted to leaving group. Now this is your trans. Now these anti-2 leaving group here, these will departed. That means here you will get a carbocation. Then anti-2 leaving group means anti-2 leaving group. This is your leaving group. Anti-2 this bond means this bond is anti-2 this one. This bond will be migrated over here. That means this will be a ring contractions. So here there is a no H, no other OH group. This bond will be migrated. That means ring contractions will be taking place. So that is why these things will be here plus charge and ring contraction will be taking place. That means you will get like this situation. Here you will get like this situation. Ring contractions will be taking place. So then here these things will be there, and after that this bond here bond was there. This bond will be goes over here. And now here immediately you will get here already this bond is came, and with this bond here outside situations will be there here, and here you have a OH and here you have a plus. Situations will be like this. And after that you know very well. After that you know very well this situation. That means here 5-membered ring, outside of a 5-membered ring aldehyde group will be there. So that means what you are getting over here itself, if you look at very clearly, and then here product is, if I write down final product, that will be 5-membered ring, 5-membered ring outside of the ring, like this situations is there. That means aldehyde group is there. Here 1H and here carbon is there, C double bond O. These will be your final Ma. For the trans, these things is nothing but this is your major product Ma. So that means the basic idea of this reaction is nothing but what? One thing I explain, the anti-stereochemistry is nothing but anti-2 leaving group migration. So that's why whenever the cis is there, the hydride is anti-2 leaving group that is migrating. That's why cyclohexanol is a final product. But whenever trans you are taking in a cyclohexane 1,2 diol but trans, then what is happening? Anti-2 leaving group migration means that both are equatorial OH-OH, and then anti-2 leaving group means there will be only possibility there is a ring contraction. So that's why ring contraction used to taking place, and you used to get that the 6-membered ring is converted to 5-membered ring, and outside one CHO group will be there. That will be your final product. Is it clear or not? Everybody understood? This is a very important model, Pinacol Pinacolone rearrangement. I hope I able to give you clarity by these lectures. So thank you very much. Thank you all. So to get more and more this type of model problem, come and have a watch my channel. So I am praying for your upcoming JEE advanced exam. Best of luck each and everybody. See you in the next video, my dear student. Thank you all.